Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Brothers Chaiken, University of Albany, and his brother Joel Chaiken. Hello. Today's a big day. We started in the middle of August of the summer of 2020, and we have finished our first practice test. We went through every question. People wonder, where are these practice tests coming from? We do not want to use any of the 8 practice tests that the SAT people put on because you should be doing those questions yourself. If we do those questions, then when you take those practice tests, you will have seen the question and your score would be skewed. So we have to notice on the SAT, there were 2 practice tests that are missing, Test 2 and Test 4. But somehow, in the years before, I was able to download these and get these. We are doing 2 practice tests, Secret Test 2 and Secret Test 4. We just finished Secret Test 2. Now we're going to move to Secret Test 4. These are unposted on the SAT, but they were posted at some point. Okay, that being said, hello everyone. Congratulations to us. We went through our first entire SAT. Now we're moving to another test. So we're right back to no calculator section. Test question 1. That being said, here we go. And Seth and I have not seen these questions yet, so we are doing these cold. Question 1. Which of the following expressions is equal to 0 for some value of x? So we obviously have to know something about what the absolute value sign means. If you don't know what the absolute value sign means, you can't do this problem.
Well, remind people what the absolute value sign means then.
Well, in practice, the absolute value means that the answer is always positive, always greater than
0.
So whatever's in here, you take that number and you just make it always greater than 0. So negative 3 is 3 and 4 is 4. What it represents is the distance away from the number line. Distance is always positive. So it's
from the origin of the number line to the number.
Right.
Distance is the positive. Is the length of the line, and it's considered to be positive unless it's 0. So that's the geometric significance.
Right. Exactly.
Yeah.
Exactly.
Could you draw the graph of the absolute value function?
Why don't we finish the question first?
While you draw, I'll draw the graph of the absolute value function while you're talking.
Anyway, so which of these is equal to 0, some value of x? You just look at the different choices, and you see that if you have dyslexia or problem with reading left to right, right to left, this could be a disaster.
Sorry.
Because you can see things differently. But it's this. In order for it to be 0, this is 1 minus 1 is equal to 0. When x is 0, then this guy is equal to 0. I'm obstructing I'm obstructing the thing that I circled. Okay, so I don't want to obstruct it, but this is the answer. Okay, so that's it. I mean, now Seth's drawing the absolute value function.
Yeah. So we could tell when I looked at the problem, first they made it easy by putting the true choice at the beginning. Right. And what you could notice is that there's this minus sign sitting there.
Yeah.
And in all the others, one of the terms being added is +1.
Right.
Now, absolute value of anything can never be negative. So there's no way any of these 3 could be 0. Right. And the only one that could be 0 is this one.
Right.
And by taking x to be 2, we get the absolute value of 2 minus 1 is the absolute value of 1, which is 1, and 1 equals 1. And 1 minus 1 equals 0. So
yeah,
pretty easy question.
Great.
But of course, the thing to review is what absolute value is.
Right.
Yeah.
Okay. Oh wow, this one we're done. But I do want to ask. I do want to have like an after party on this one. I'll have one comment about the absolute value function that relates to calculus. The other one is I actually have a question for Seth. So first of all, we say goodbye to everyone. Have a good day. Like us, dislike us. Give us your comments. This one we were able to get through very quickly, thankfully. And if you have any math SAT questions you want us to go over, please email us at satmathquestionoftheday@gmail.com. Okay, now for the after party. First of all, could you ever have the absolute value of a complex number? I mean, it means the rate, but this never.
Well,
never see
absolutely, yeah. No, it's a generalization that is a key part of the theory of complex numbers.
Oh God. Okay.
And what it is, you think of the complex numbers as being points in the plane.
Right.
So x plus iy could be considered the point xy in the xy plane.
That's right.
In that case, the absolute value is just as you said. It is the geometric distance between the origin and the point.
Right. It's this distance, right? Okay.
Yeah, and as such, by the Pythagorean theorem, the two components of the complex number x and y, by the Pythagorean theorem, that distance is the square root of x squared plus y squared. Right. And of course, the square root is x squared plus y. So with that form of complex numbers, x and y are real numbers.
Right.
X squared plus y squared is, of course, greater than or equal to 0. Yeah. It's 0 only when both x and y are 0. So so x squared plus y squared is greater than or equal to 0. So a real square root exists. And then the absolute value is the real positive square root.
Right, and
it's an immediate generalization. It's a key part of the theory of complex numbers. It applies all over the place.
Right.
The answer is yes.
And it's called the magnitude of the complex numbers. Am I right?
Yeah.
It's called the magnitude.
Yeah.
Okay. So what are the quick questions? Comment about absolute value. With respect to, if anyone, not too many people are taking calculus now because you're only in 11th grade. But calculus has to do with the way things change. Like everything in life changes, and calculus is sort of the study of how things change. It's really important. You can't really do anything in engineering or science without calculus. But notice that there's a sudden change here. When you see calculus, it should be warning. See, there's a sudden change in the graphs of value function. See how it just goes from one thing and then changes suddenly? See that?
The slope changes. The slope changes from -1 to +1 as you go through 0.
But it changes abruptly. It changes literally abruptly.
Yeah. So in calculus, we say that that at 0, the slope is discontinuous.
Right. Well,
it changes, as Joel said, it changes abruptly from -1 to +1 as you pass through 0.
And
you could say also it's undefined at 0.
So so what this means basically in life is that anything that changes abruptly in your life is not it's not a good thing. It's not. It's scary. It's scary. It's scary when things change abruptly. So the absolute value function is when you get to calculus, you don't want it there. You don't want it. You don't want this. This is not friendly, as opposed to, let's say, things in life used to, where they're very smooth, right? Things go along. Yeah. Sudden changes, abrupt changes in a function.
Yeah.
Spell disaster in life, and in calculus.
Well, the changes. Let's be precise.
Okay, go ahead.
The value y equals absolute value of x. As x changes, the y changes continuously.
Right.
But the rate of change of y, which is the slope, and is called the derivative in calculus, the rate of change, or the slope, as you can see in the graph, changes abruptly from -1 to +1 as you move from -x to +x.
Right.
And you add another thing, the slope doesn't even make sense right at x equals 0.
Right. Right. Yeah.
Right. So in calculus, you have to take care to distinguish between values of functions and the value of the slope
I know, but now you get
at a point in the curve. That is critical.
I know, but you're getting this is not a
So if
calculus
people are going
class.
to learn calculus, they better, that's what it's about.
I know, they'll get to that. Oh, they'll get to that. That's a detail. That's a big detail, but they'll get to that.
The devil is in the details.
Just making a comment that whenever I personally see the absolute value function, I don't like it because it has weird characteristics to it, which you'll learn about later in calculus. But essentially, something about this function changes abruptly, and that's not a good thing in life. You don't want things to change abruptly. Maybe something good to change abruptly is good, but most of the time when things change abruptly, you want to avoid that stuff. So, I guess anything else about this? Huh?
Well, if you want a function that gives you information, something like the absolute value, and you don't want it to have a discontinuous derivative, you don't want its slope to change abruptly, you could take the absolute value squared.
Yeah, but that's
or in real if you're dealing with real numbers, all you do is instead of the absolute value of x, you take x squared.
Oh, I see what you mean.
And you plot that, and you get a curve. You plot x squared.
Right.
Plot the function x squared, and there you go.
Look at that. You get nice smooth.
Yeah.
And I guess you could phony this up with different parabolas and different x's and y, a, b, c's in the parabola to make it sort of go like this, right?
Yeah.
Oh, I see what you mean.
You put a multiple of a. You put a coefficient ax squared, positive a times x squared. Yeah.
Right. Yeah. So maybe that's right. Hopefully.
Now in complex variables.
Oh, come on.
Instead of z squared, what they do is use the absolute value squared, which is with x, the absolute value squared of complex number x plus iy, that is x squared plus y squared.
Okay.
Which is much nicer. Which is much nicer.
Yeah.
Than the absolute value you're talking about, just for the reason Joel said.
I think you lost most people on that, including.
Well, we're going we're going beyond the rim of the cup at this point.
we're over the rim of the cup. We're drowning right now. Yeah. So I think we're done. I think we're done. Okay, but anyway, that's a comment about the absolute value function. Okay, so. I guess have a great day. We'll see you other way, right? So on Wednesday, just for people who are watching this continuously. Oh yeah, talk about continuously, right? With no breaks. On Wednesday we had a problem with our video. So we not a technical problem, but a content problem. And we needed to interrupt the video, so that will post over the weekend. Okay? You'll see that one of us, I'm not gonna say who, wrote down a formula that was completely incorrect. So we had to put a break in the video and say, don't use this formula. But I'm not going to say who did that. Okay, you'll have to watch the video. Okay, everyone. Take care, everyone.